Here's an example in which we're converting polar coordinates to Cartesian, and they want exact values. So let's let me rewrite this. This is 6 comma 5 pi over 6. So how do we change that to Cartesian, or normal, or it's also called rectangular xy, right here, xy coordinates? How do we do that? Well, if you go to the notes that I provided for you at the top of Module 5, the Chapter 10, 3, 4, 5 notes, you'll see converting polar coordinates to rectangular. You start with the polar coordinates r theta. X is r cos theta, y is r sine theta. So I go, oh, okay. So the x is r cos theta, so it'll be r. Oh, and by the way, this is the r and this is the theta. So r 6 cosine 5 pi over 6. Now we can't just go to our calculator, because if you go to your calculator, you'll get a decimal. Here, I'll do it real quick and show you the decimal you would get. You would get minus 5.196, but we can't get a decimal because they said exact values, right? I rounded that decimal. That decimal actually goes on and on and on forever, actually. So you have to round it, and then it's not exact. Does that make sense? When they say exact values, that means no decimals. No rounded decimals, I should say. No rounded decimals, because when you round a decimal, it's no longer exact, it's rounded. And this decimal goes forever, so you'd have to round it, and then it's not exact. So we can't do that. What do we do then? Well, we go to the unit circle. Whenever they want exact values, that always means unit circle has the exact values. That's what we always do when they want us to do a sine or cosine and they want exact values. So here is the unit circle. What angle were we at? 5 pi over 6, right? Yeah, 5 pi over 6. So 5 pi over 6 is right here. This is the cosine and this is the sine. We want the cosine right there, negative root 3 over 2. So it's actually going to be, so the x is going to be 6 times negative root 3 over 2, right? The cosine of 5 pi over 6 is negative root 3 over 2. And then how do we simplify that? Well, a whole number is over 1, so it becomes negative 6 root 3 over 2. Good so far. The 6 multiplied the top and the 1 multiplied the bottom, because that 6 is 6 over 1. And then you can reduce that. 2 goes into 6 3 times, negative 3 root 3. So there's the x value, negative 3 root 3. That's an exact value. It's not rounded in any way. Now let's get the y value, and according to the formula here, x is r cos theta, y is r sine theta when you're changing to rectangular. So y is r sine theta, which is 6 times the sine and the same angle, 5 pi over 6. We know we need an exact value, so let's go to the unit circle again. 5 pi over 6. There's the sine of 5 pi over, there's the sine of 5 pi over 6. It's a half. So that'll be 6 times a half. A half of 6 is 3. So there we go. The y value is 3. So we were able to get the exact values. We changed from polar coordinates to rectangular. They gave us polar coordinates, and we were able to change those to rectangular. Now, I want you to see where that formula comes from. So why did that even work? Because if you think about it, what are rectangular coordinates and what are polar coordinates? Rectangular coordinates are like x and y, right? You find a point, x, y. Polar, how do polar work? You turn to an angle. So if you're at some point here, over x, right? Over x up y, over x up y, then you're at an angle theta at a distance r. That's the same dot whether you call it r theta or xy, whether you think of getting to that dot through polar movement or rectangular movement, right? Rectangular means go over x, up y, boom. Polar means turn the cannon to the right angle, theta, and shoot the cannonball down that line a distance of r. Boom. Either way, you land at the same spot, called r theta or xy. Well, do you see the connection now, why that formula works? Because we have a right triangle, so we can use SOHCAHTOA. I'm just proving to you where the formula comes from. And if you wanted to take, because the problem is over, at this point I'm just proving to you where the formula comes from. If you take the sine of theta, that's opposite over hypotenuse, right? That's y over r. And if you take the cosine of theta, this one is the adjacent side, cosine is adjacent, so that'd be x over r, right? Adjacent over hypotenuse, where sine was opposite over hypotenuse. Okay, great, so what? Well, now if you put this over 1 and go diagonal, diagonal, same thing here, over 1, diagonal, diagonal, you'll get the formula. R times sine theta on this diagonal, r sine theta, is 1 times y on that diagonal. That's just y is r sine theta. That's where we get that from. This one, r cos theta, right? This and this on this diagonal. And the other two equals 1 times x. So x is r cos theta. So there's where we get those formulas that I showed you right here on the formula sheet, the connection between the polar coordinate system and the rectangular coordinate system. It's because it's just simply a triangle. If you have a dot, which you go over x, up y to get to that dot, or you could go turn to an angle theta, shoot out a distance r, same dot, x, y, or r theta, the connection there with that right triangle is that the x value must be r times the cosine of the angle, and the y value must be r times the sine of the angle. That's clearly true, just from the right triangle SOHCAHTOA trigonometry that you already know about. So I just wanted to show you where the math formulas come from. I don't want you to think of them as magic tricks. It's just logic. It's just clear logic. Sometimes it's not clear until it's explained, but I hope now it's clear. That's how you connect the same point in xy coordinates and r theta polar, in rectangular coordinates and polar coordinates. Same dot found in two different systems, and the connection between those systems, the x is r cos theta, the y is r sine theta, and so I just do that. I take the r theta, x is r cos theta, y is r sine theta, but I had to get exact values, so I had to go to the unit circle to get, that's how we always get exact values, is the unit circle here has exact values for us, doesn't it? All right, the unit circle has exact numbers instead of decimals. So that's what we did. Go to the unit circle, find square root of 3 over 2, and simplify everything.